Absolutely. So it's 2 minutes past and we've kind of leveled off. So I think we can go ahead and get started. Welcome, everybody. We've got a lot of great information to share with you about our various Masters of Science in Engineering. So we'll go ahead and get started if we want to go to the next slide. I'll introduce myself first since I'm already talking. My name is Victoria Bray. I'm the Associate Director of Recruitment, and I work with all of our School of Engineering master's programs and their prospective students and admitted students. Ted, would you like to introduce yourself?
Well, thank you for your time. Good to see you all today. Ted Tracy here. I'm the Master's Program Director for the ECE discipline, and I'm also a faculty member teaching 2 or 3 different classes in the electronics and computer engineering area.
Fantastic. So we can go to the next slide. So we're going to cover a lot of stuff today. We've got a lot of really great information to share with you. We're going to talk about the master's program, the structure, curriculum. We've got some distinctive portions of the program that we really want to highlight. We'll talk about Brown. Brown's a unique and special place, so we've got a lot of information and resources to share with you about Brown University in general. And then we'll talk through the application requirements. Just like we were talking about before, we're going to use the Q&A on the Zoom toolbar to collect your questions. I will be and Anne will be answering questions in the background as we go through the session, and then we will leave some time at the end for a Q&A as well if you want to save them for that point. That being said, we'll add our email addresses to the chat if you have any questions. We sent out a message also about waiving the application fee for attendees to the event, just so you folks know now. You don't have to ask about it. We will waive the application fee for anybody who's applying to the engineering master's program for this cycle. Based off of your attendance to the event, we match the email address that you use to register for the event to the email that you use to submit your application. So if there's any issues with that, you can reply to the messages that you got reminding you about this session and we can help you troubleshoot. But we are planning on offering those application fee waivers. So if we want to go to the next slide, I will hand things over to Ted to talk about the master's directors.
So I am a master's director for ECE, as I mentioned, and I have many colleagues that are doing similar things for different disciplines, whether it's Marissa for biomedical, for example, or Mike, who really worries about our data science initiative. So we have different people that are specialists in those disciplines. That means they're very familiar with the classes of interest, and we work with you very closely to create a program for you over the next couple of years while you're getting your master's to really get the most out of the program you can. So I'm paired up with Nora. She's an academic professor in computer science and in engineering. But I also give a little more of an industrial feel to what we're doing because I come from industry and I can help you advise on those people that want to make it back into industry, for example. Next slide.
We also have a really great group of student affairs staff who are there to help our graduate students navigate Brown, navigate Providence. So depending on what program you're in, you might work more closely with one of the folks on the screen than others. Anne Lang, who's on the call, she's answering questions. So really folks that are there to work with you from the time you express interest in Brown, start attending these sessions, all the way through to when you graduate. So they're there to help connect you with vital Brown resources, help you network within your program and within the School of Engineering, really anything that you might need in terms of administrative support, student support while you're at Brown. This is the group of folks who are there to help you. So if we want to go to the next slide, I'll hand it back over to Ted to talk about the program.
Yeah, I'm going to walk you through the overall engineering approach, but I think what we show here, which is kind of symbolic for our School of Engineering, is this infinity sign, which is on the front of our beautiful building of now 7 years. And it really shows that we have a lot of flexibility in our programs. We have an infinite amount of flexibility. If we have 100 students, there's probably not two that have the exact same program. So there's a lot of variability in the options you choose, and we encourage that. And we feel like there's infinite possibilities in your program ahead. Next slide. And I think also, being around Brown for a long time, we think it's really a great time to come to the school. You get to design very unique programs that may be very timely in the industry, for example. Next bullet, please. And there's also just a wide range of different research going on around the campus. So if you want to augment some classroom work with some unique research, it doesn't have to be in the School of Engineering. It could be in the School of Medicine, for example. So we encourage that type of flexibility and interoperability. Next couple bullets are fine. And we feel strongly that we have a very nice scale to the university. So most of the professors, people like myself, are very approachable. We'll know all the students on a first name basis typically. And there's a really good opportunity to connect with those leaders to actually get into their research areas or maybe do some advanced study in certain curriculum that you're really interested in. And then just from a physical location, and Victoria will talk more about this, but Brown is located uniquely between a couple of very big cities. And we like it that way. We can get to those big cities if we need to, but we really got a unique campus and a unique scale. Still very cultural, still very intellectual, and at the same time, very private for you to enjoy the New England environment. So we'll talk more about the environment in general, but Brown is unique in this capability as well. Next slide. And again, being around the program, I went to Brown, and I've had kids in my family have gone to Brown, and I was a member of a family that had 6 people that went to Brown. So I know a lot about the school just for whatever reasons. And I really see in perspective that it's a great time to join the campus. For one thing, we are actually growing the school. We're growing the leadership and also the number of professors that we have. And growth brings new opportunities, new research, new classes being taught, new opportunities. We are very flexible, as I mentioned multiple times. You have a variety of different degrees we can go after. We feel like we're bringing some innovative new courses into the mix. Some of that because of the new professorships, but also just because we try to look at problems slightly differently. And we have some new programs that are cross distribution in nature. So it could be a shared opportunity with RISD, for example, if you're really into design, for example. And all that is happening, and it's very positive and heading up and to the right, as we say. But the biggest factor at Brown we see is that we just continuously get great students. And I think you notice that when you interact with them on a day-to-day basis, as I do. It's a relatively easy job to be instructing students when they're really capable and motivated. And I think we see that at every level, at the undergraduate level, at the graduate level, at the postdoc level. Next slide, please. And we have, by the numbers, a fair amount of things going on in terms of different programs. We have about 430 graduate students. We see the breakdown here in the green bar. Very well represented from a diversity point of view. Brown has always prided itself on being a very diverse environment. So you see those numbers there. So you're going to have an opportunity to learn from a lot of different people from across the globe is really the key. And again, a lot of flexibility in the types of areas that you study, but also the people that you're studying with. Next slide. And with that, we have, the traditional doctoral programs for some of the traditional science areas. Electrical and computer engineering is one, but we have chemical and biomedical and fluids and materials. So on the left-hand side, you see very standard programs that people would get a very advanced degree in. On the right, we have a little more new things happening. We have different master's programs, masters of engineering. And sure, we have things like a master's of engineering in biomedical, for example, and we have one in electrical and computer engineering for sure. But we also have some things like MADE, for example, where you get a degree in design, or the Prime, which is a technical leadership type position for business. And so we are creating these new opportunities to give people what they want, which is really a mix of different skills, both on the engineering or technical side, as well as on the business side. And then at the very bottom, what we're very excited about is a brand new program called the Sustainable Energy Program. Clearly, sustainable energy is something that we all in society feel like we need to have. It's a heavily affected industry by the governments of the world. But we are studying both the technical aspects of sustainable energy, but also the policy enforcement of that as well. So you need both those areas. And this is a new program just starting up in the last couple of years. But there's a lot of interest in that, for example. Next slide. And as I mentioned, the good news is that we're bringing on new energy. We're bringing on new professors that are young in their career, and they're bringing in their research from previous institutions that they worked at as part of their doctorates. They may be bringing in different labs and different members of their prior teams as well. So we're excited about bringing on these 5 new members. 5 at any one time is a big number for Brown. And so we feel excited about bringing in several into the electrical and computer engineering area, but also in biomedicine and in some of the areas that we influence as well. So we can read about these guys, and usually what happens when I connect with students, we get specific, like very specific about what classes they may take in their first semester. And often I will direct them to some of these new exciting opportunities that we have as well, because we feel that's some of the new energy that you want to see. Next slide, please. So when you get into what is the program all about and how is it structured, that's where we'll spend a little time talking about this in the next few slides. There's a scholarly track, which really means you're coming to Brown to get a re-education on certain academic issues. You're spending most of your time in the classroom. You're working with people for sure, but you're really learning the academic side of the information. If you're kind of coming to Brown because you really want to go deeper into an area and understand world-class research in a certain area, and study something to a much deeper degree, probably to go on to get a PhD at some point, or maybe go back to industry to do, real research in that particular area. We also have a research track. Typically that means you're doing classwork, but you're also going deeper and actually doing a thesis as well. And so that's going to take some time. And some of the 8 classes that we allocate to the masters would be dedicated to the very specific research that you do. And if you come into Brown to do something that you're trying to get into industry or go back into industry in a certain different trajectory, then there's a professional track that we work with you to get the training that you need in the classroom, but then also target a certain vertical that you may want to go work for, and then specifically a company. And hopefully that company is a partner of Brown's, and we get you to go work for them and really understand what that industry is all about. And they get to know you really well on a personal basis over the course of a 3 or 4 month stint. And so this is like an extended interview process, and one that's a really good way to kind of re-inject yourself into the industry. Next slide, please. So let's talk a little bit about some of the courses that you may line up to. Let's go through that. And so I always start with the ones that I'm most familiar with, but Pepe is one of our new professors, and one of the things that she's bringing to the table is cloud computing. So what we're talking about is reconfigurable computing, and specifically, how do you allocate CPUs on demand to solve important, complicated problems? And they could be problems related to mechanics or material science, or analysis of detailed structures, or it could be machine learning and understanding of large language model problems. But in general, industry is clamoring for more compute power on demand. And we're studying how to do that effectively, both at the CPU level as well as things like field programmable gate arrays, if you're into that type of logic design. And so this is a whole new area that's a good example. Bringing a new professorship into the group brings in the new topics that we really can learn from that are really leading edge. Next slide, please. And along with that, one of the other professors, Professor Salindi, is actually very expert at systems on a chip design, and specifically, high-end integrated circuit design. So he's teaching a class that he developed at University of Michigan, and he's bringing it to our class to show people how to do the next level of systems architecture and actually develop systems that are on a chip. Now, we look at things like the iPhone today, and the iPhone probably at Apple has a team of 500 people developing that, and it's a system on a chip, but it all fits in our hand. This is the future of our design work, and we're trying to learn the skills and the techniques to be able to enable Brown engineers to do that type of system design as well. Next slide. And it isn't all about computers and electronics. We have some great things going on in traditional areas like fluids engineering. We're very strong in that particular area and have been for years. But what we do in a little different way for Brown is we look at the artistic value of fluids. And so, sure, we're going to understand the phenomena of fluids, but we want to see, like, how can we image and understand these different phenomena more closely, more effectively, and more in an interesting way. And we've actually made an art exhibit about this that's in our front lobby of our engineering resource center as well. So sure, we're going to study the basics of the engineering, but we also notice some other cool things about the areas, and can do things like advanced photography and imaging to allow us to study that more closely. Next slide. And one of those areas that's a little more practical and useful is optical microscopy. Now, this is an area that's a cross between physics and engineering and medicine and biology. But there's a set of professors around the university that are really expert at optical microscopy. And a lot of times this is used for cutting edge research that could contribute to a Nobel Peace Prize, for example. And we're trying to understand, what does it all mean? What is it all about? How do we use the tool? And how do we actually access that type of tool to use it for our type of research as well? So this is Kamani, who's a dean of the university as well, and actually is an expert in optics, and is really focused on trying to make this a class that's really interesting for the graduate student that we bring in. Next slide. And this is actually my class, which is a radio engineering class. We called it microwave engineering. I think technically by the book we do, but really what I'm trying to do is bring it right up to speed into the latest areas of high-speed communications for devices, specifically like iPhones and Wi-Fi devices and Bluetooth, et cetera. And we spent a little bit of time at the beginning of the course learning about Maxwell's equations to understand how radiation works at high frequency. But soon we try to move into the more practical recent developments, things like Wi-Fi, and really understand like how antennas function effectively, and how do we build digital systems that radiate and actually connect to other networks of such systems. So really trying to make this very important device called the iPhone meaningful to people, and really understand how it works and functions. and to show how classical areas such as electromagnetic radiation can be used more effectively in the digital world to really turn that into a skill that we can develop really cool stuff with as we go. Next class, next slide. And then this is a little different project that is going on right now. It's a capstone project, and we do allow grad students to do things like capstones. And in this case, we're actually building systems. And so what we're doing is the only requirement is we want you to build an embedded system that would have a microcontroller in it. And we will allow you to do a schematic design and a design of your choice of any type of product, any type of market appeal or target that you go to. But you actually will see it through from start to finish. You'll do the logic design up front. You'll do the detailed hardware implementation, the selection of the components, the layout of the circuit board, the systems issues associated with things like an antenna, for example, which you see in the middle picture. And then we want you to build an electromechanical package around it as well. So if you want to get the visceral feel of actually building something that works and is under software control, that's a project, the class that we offer, encourage, and a lot of people have a lot of fun with it. It's cool to be able to design something that you've always been interested in doing, and you actually given the time to go do it. Next slide. And it isn't all about technology. We have business classes and emphasis on entrepreneurism as well. So we do have the school, the Nelson Center for Entrepreneurship, which many of our engineering students try to get a class in as well because they're trying most likely to innovate or build up, be on a team where they're building a company or a new product. And we're trying to give them the skills to understand how to bring that to market. And that's a very common model, though. We have technologists that want to be business people as well. And so we can get your science degree and we make sure very strictly how many classes we take in each of the types of departments. But while at Brown, you may have the opportunity to get some business exposure, either in the Nelson School or possibly at Harvard. We have a cross program with them as well, to get just a little more rounding in terms of how you view your technology career is going to develop and what types of skills you need there. And in this particular case, Professor Banu is talking about how organizations work, how to be effective in an organization, how to lead in organizations. And these are all important soft skills that people can develop that really will help quite a bit in the development of the career as they go. Next, please. I'd mentioned the Sustainable Energy Program, again, just in its second year at this point, focus on very detailed technical aspects of how new energy actually works, the different types of solar and wind, and in things that are not fossil fuel type systems that we worry about. But then also we try and understand the appetite around the globe for where these technologies can get deployed and some of the policy aspects of that as well. And there's always a business equation that has to be solved in the middle of this as well. So this is a way to kind of really learn the basics of that field. If you wanted to re-inject yourself into the industry of sustainable energy, it would be a great way to get the training that you need to go on and make an impact on that in the world. Next slide. So one of the questions will come up is that, do I want to really go deep into one area, really want to focus in a targeted way and do a deep development and a research and a thesis with that? Or do I want to be broad and really cover a variety of topics? And you don't have to make that decision, certainly not when you're applying. You don't have to make that decision when you get admitted either and you decide to come. But generally, this is one of the roles of the academic advisor is to actually spend time with you to see how your development is going and see probably by the end of the first semester if you think you want to be thesis-based or non-thesis-based. And that means you will be one of the two tracks that we mentioned earlier of the three tracks that we have. Now, to be able to do research, that takes a little work on your side to connect with a PI, a principal investigator as well. And usually the best way to do that is you take a class that's very interesting to you. You get to know the topic and really understand that that's what you thought it was. And you get to know the instructor for that class. And that instructor for the class typically will have a lab that's doing research in that area. And you would try to introduce yourself and get connected to that group. And you'll meet other grad students that are in that group as well. And if there's something that really clicks and you like the vibe, and you like the aspects of the research they're doing, and you like the people, then you ask to be part of that team. And if that's the case, then you have a really good supporter to go off and do a thesis with. We don't really have a very high attendance in terms of thesis. I think it's somewhere between 15 to 20%. It's not that common, but if you really think that you're going long distance on a certain topic and probably go do a doctorate at some point, it makes a lot of sense to get good at doing research. And so that may be the kind of thing or skill that you want to develop at Brown. You have that within your set of options that you have. So very flexible on that. But many students let's say the remainder, probably like 70, 80%, probably don't do a thesis. And they're really just looking for a broad range of classes. And sure, they'll do more intellectual research and homework type things, but they're not really taking the time to write a thesis, which is a significant course requirement to kind of get through all that and defend it properly as well. Next slide. And then if you're doing thesis, then there's a set of questions like what areas, and the research is a big part of that. Let's go look at some of these different research areas that are topical. So one is in a traditional field like fluid mechanics, for example, or mechanics or things associated with fluids. And this brings up a really good example before is like, we absolutely have fluids studies and wind tunnels for aerodynamics and things, but we try to apply it to unique environments as well. So for example, if we want to understand how fluids actually will penetrate a coastline, for example, the state of Rhode Island is probably 50% covered in water or bordered by water and ocean. So we have a great opportunity to study exactly how that happens. And so we're trying to do it for the ecological benefit of what is the mechanics and the physics behind that. A lot of research, a lot of data science involved with the modeling of these types of phenomena. So, we have different ways to take the basic theory of fluids mechanics, for example, and really apply it to kind of interesting and important problems that we're trying to solve in society. And we have all kinds of grants and data research behind to help support the analysis of those models. Next slide, please. And lo and behold, this is a Anoop who is now a PhD student, and he is a fluid mechanics major by PhD major by day trade. But what's interesting about him is he got into studying drones because what he noticed is that the propulsion patterns of the drones was very similar to the problems that he was seeing in fluid mechanics. And so he kind of, as we joke, he at nighttime he's studying how drones work. During the day, he's studying how fluids work. But that's a good example where someone who is able to kind of take the traditional and the advanced or the new and merge them together into a very unique field. And as you know, as a PhD doctoral student, you have to be unique in your contribution. So Noop is really finding his niche between those two extremes and is really good ambassador for our program. I often ask him to speak to candidates like yourselves to kind of show what some of the PhD and research opportunities are at Brown. But he came up through the ranks as a master's and has done a great job with that. And now he's moving on to something more advanced. Next slide, please. And then we have a long history of biomedical engineering. Maybe it only became evident during COVID because we did such a great job in contributing to the public health aspects of that. But we've had a long relationship between the med school at Brown and the biology department as the engineering department. And I personally think it's because the miniaturization of a lot of the electronics and the capabilities that we have in terms of optical spectroscopy and such, but also the ability to design chips and simulations for the human body. So there's a lot of this collaboration going on between different departments. And right now, our biomedical engineering is probably our leading concentration in terms of undergraduate candidates, and we see it at the master's level as well. So, very popular field, a long history of innovation in this area and collaboration between different departments. And I think that's going to continue to increase as we get advanced technologies and the ability to solve problems like COVID more effectively using some of the tech as we go. Next slide, please. We have a data science initiative we call DESIS, as it's shown here as the acronym. A lot of research going into how to use computing more effectively and to make that a resource throughout the campus for all types of research being done. A lot of it is driven by things like fluid mechanics modeling. But I'm sure with the world of machine learning that's kind of going crazy right now, we'll need every bit of compute power we can get. And so we'll be involved with that at some level. And I think that Mike, as a program manager, really does a great job of leading the data science and having it be connected to what's happening in industry. So Mike Donahue may be a guy that you want to connect with if you want to know a little bit more about this type of program as well. Next slide. And one of the areas that we're collaborating in is a digital health initiative. And this is kind of unique in the sense that, most research and funding at the grant level is focused on PhD research. This is a program that's actually focused on master's research. It's called Breath, and it's a combination of different technologies like the optics of wearing devices, and then also sensors, actuators, and things that are going to be available for digital health, possibly stimulation inside the human body. and also signal analysis. And so it's a kind of mix of different things that would be very good material for a first level master's type candidate. And it's really, a topical class. It's just getting going, and we're getting funding as well, which is always a positive sign. So this could be an area if you really wanted to understand digital health, as an example, you could do some research in to augment the classwork that you're doing as part of your curriculum. Next slide. And then there's electrical computer, and this is probably the program that's been around the longest, but we've been involved with electronics for a very long time, since the beginning of the integrated circuits. And, back in the 70s, we were involved with the lunar landing of electronics, and Bill Patterson, who's pictured here on the left, actually was one of the inventors of the camera that went on the Mars rover, for example. So we've been involved with a lot of this, and we understand devices very well. We understand communications very well. We're coming up to speed with computing because that's what the infusion from a couple of the new professors are bringing up to us as well. But lots of communication expertise, a lot of photonics as well. And the area that I think is really important are things like signal processing. As we develop new radios and transmission systems, there's a wealth of opportunity there as well, since the compute power has become so great and we're learning more about how to transmit at very high frequency. Just a lot of great areas of research going on here. Next slide, please. And as I mentioned, we have some cross pollination going on with other schools. Here's one that's pictured. It's a program called MADE. And if you really want to understand how design works in the industry today, and design is obviously a very important factor. We see that with our smartphones and our home devices and things like this. There's a lot of emphasis on usability of products. And so we have a great partner with the Rhode Island School of Design, RISD, that allows you to have a cross training that's a mix of engineering classes, typically mechanical and electrical engineering classes, mixed with design classes, and that can give you really a world-class training to go off and to develop some of the greatest new products that are going to come about. And so MADE is a great program. It has a slightly different cadence in cycle. The guys can tell you a little more about the cycle on that particular class, but it's a really unique opportunity to really study both design and some of the key technology areas that you want. We also have cross-training programs with Harvard. Typically, people want to take some type of business class, some kind of entrepreneurship class as well. That's all possible to integrate into your eight course curriculum that you design, but it's not a formal program like the MADE program is. Next slide, please. And then the thing that I'm kind of really focused on and trying to make happen is the ability for you to take your master's degree, because I think when in many schools that gives you the depth that you need to be really effective in industry, and to go into industry and actually work with a company that you think is the right company to go work with, or the space that you're interested in going to. And so we call that the co-op program. It's not a summer internship for 6 weeks. It's meant to be a 6-month program where you go into work with a company who's a leader in that space. They put you on serious projects. They know they have you as a resource for 6 months of time. You get to work in depth to really get a feel for how that industry works. And maybe you like it and maybe you don't, but you made the investment of your time to learn about that. By the way, they pay you to do that very handsomely. So it's a business. You're doing a business role for that period of time. It's very technical. And then you can still come back to ground at the end of that 6-month separation and actually finish up with your degree. In fact, we will have you do some training before you take the co-op internship in the industry. We'll make sure that you know how to integrate with the company and present yourself effectively, and that you have the basic communication skills that you need to do a good job at that company. And then at the end, if things go well, then the goal is hopefully they make you an offer to come on full time after you get your master's degree. If you do this type of program, it's going to be a 2-year calendar program. You'd be about roughly 18 months in the classroom and 6 months working for the co-op. And that will be a really good balance of activities to kind of get you reintegrate into a new possible job role. Next slide. I think we have an example of Will. And Will is a really great example of this. Now, he came to Brown 25 and got his ECE master's degree, mostly classroom training. He learned a lot about robotics and embedded systems. He got partnered with Amazon, and he worked on their Proteus product, which is really their manufacturing environment robotic system. And so this is a world-class leader, clearly using world-class technology, and he had a chance to see what happens in real life with the real operating environment, different than what he did for homework sets for 18 months on the campus. And so he really got a great exposure to that. What he interested in, he did a really great job with them. They got to know him very well. They made him an offer at the end, but he decided at the very end of this all to come back and get his PhD. So he's actually back getting his robotics PhD at this point because he got so motivated by what the work had been at Amazon. But he's a really good example of someone who went through the co-op program, working for a really good company, making some good cash in doing so, and really getting a good balance to the training that he had in the classroom. Next slide, please. And so this all gets kind of complicated because I've shown many slides of many different courses and possibilities and such. So we don't just throw it all at you. We have a handbook for every discipline that we have. In this case, in electrical and computer engineering, we kind of know that students fall into usually a half a dozen different templates. And so if you have like medical imaging or biomedical interest, for example, then down the top, you might see a template. These are kinds of classes that you should be looking at more closely. And you could be looking at these today. They're all publishable on some website that you can get to, I'm sure. And you can start understanding the kinds of classes that you'll be taking to get that degree. On the bottom template, for example, if you were interested in doing communications products or signal processing or image processing, and you want to do professional track, that means that you would spend, 3 courses in your first semester, 2 courses in the second, and then that summer term you'd work for a company, and we have a nominal proxy of a course where you're actually working with the company. And then when you come back in your last of 4 semesters, you would actually take 2 additional classes, and that would give you the balance of eight courses. And those courses would typically be from this group that I've shown here that show the different types of signal and image processing that we allow for this type of major. And then there's 3 or 4 other templates behind that. But that all being said, these templates are a starting point. It's often the case that a student will pick some additional class, or maybe they want to learn about machine learning in the computer science department. That's all possible. So you make the case as to what these courses could be added to your traditional template, and you work with someone like myself to get that approved for a curriculum that you can shoot for the next couple of years that you're at Brown. Next slide. And just want to make a mention that we are very friendly to the veterans group that has supported the country dutifully for years. We have nice funding options for people to actually subsidize their work at Brown, and it's often the case. I have many in my classes that I teach of veterans that are coming back after making their commitment for the country, and they will go off and study and try to get into a new field, maybe like IT, for example. And so things like the radio communications and the computer engineering are really, really useful for that kind of background. So we welcome that. If anybody on the call is a veteran, we're very friendly to that, or tell your friends about it because this is an area that we're trying to pride ourselves in. Next slide. And so this is my last slide. And the point I always try to make here is that you really don't have any bad options with the Brown Master's program. You may not know exactly where your path's going to lead in a couple of years, but the outcomes always end up pretty positive. If you come to Brown and maybe you weren't interested in a PhD, but as you got into it, you got exposed to some research and you really got motivated by that, then our students are welcome in almost every notable PhD program across the globe. So you would have no problem applying those schools. I'm not guaranteeing you're going to get in, but you'll be definitely in the running with many of the schools if you've done a quality job of some research. You may have done research, but don't want to go into academia and you want to go into industry, then we have partners that are in the industry that are studying all kinds of problems, like Pfizer, for example, or Amazon, as we talked about Will's case in terms of robotics. And if you're just trying to get a little more exposure to some more recent technology and try to go find a job like many people are, then we have really good connections with many of the schools that are hiring in this way. And getting a job is never trivial for anybody. Getting the right job is always challenging. But we feel like we have a lot of experience and direction, and that's part of the thing that I'm trying to bring to the program as well, is to get us connected to the right kinds of companies. And so they'll feel very comfortable about taking Brown Master's students into their program. And there's several that I'm working with right now that I'm trying to help place in different opportunities. So really, sure, it's a risk, a little bit of unknown. What is Brown all about? But what I find time and again is most people end up in really good places, whether it's in research or in industry. It usually ends up pretty positively. Okay, thank you. Thank you for your time. I think that's my last slide. More than happy to talk about any questions that come up and or follow up with you after the call as well.
Awesome. Thanks, Ted. So I'll talk a little bit more about Brown University if we want to go to the next slide. So Brown is located in Providence, Rhode Island, like Ted was saying earlier. Providence is a small city. It's really well situated in the New England area in the Northeast. If you're interested in exploring opportunities in Boston, New York, Hartford, we're about an hour from Boston, a couple of hours from New York, really easy to get there by train, by bus or by car if you decide to have one. You don't necessarily have to have a car to live in Providence. It's fairly walking and biking friendly. If anything, parking is kind of challenging, so it's nice to not have a car and be able to walk everywhere. Providence has a really vibrant art and culture scene. So we have the Rhode Island School of Design right down the street from campus. They put on a lot of wonderful art events, and we get free entrance, or students get free entrance to the RISD Museum as a part of that, which is fantastic. They have a lot of really great spaces over there. Lots of outdoor space as well in Providence and further out. So Providence has a lot of parks. If you have a dog, there's some great dog parks too. And then a little bit further out, there's Burlingame State Park. If you like camping, you can camp there. But then also we have really easy access to the beaches. Rhode Island is the ocean state, so we have a really great coastline with some excellent beaches, so you can get out there as well. Easy to get around to Boston, New York. There's some great airports too. So if you need to get to campus via a plane, there's TF Green in Rhode Island, and then there's Logan Airport in Boston. So all around, sort of a really great hub to be in. It's a good launching pad if you're interested in visiting friends in other cities in the area who are going to other universities, taking classes. You get to take classes at other universities as well as a part of our partnership, which we were talking about earlier. So if we go to the next slide, we'll talk a little bit more in depth about Providence. So this is a map of Providence separated out by neighborhood. It makes the city look a lot larger, I think, than it actually is. The areas that have hearts over them are the areas that our students tend to frequent, whether that be socially, living, taking classes. The vast majority of your classes that you're going to take at Brown are in College Hill. The pictures that you saw of engineering are in the College Hill area. Brown has a wider footprint than in Providence than just College Hill, though. So, for example, I work in the Division of Masters in Professional Programs. My office is in the Jewelry District in downtown. We have the School of Public Health, the medical school are both in the Jewelry District, as well as our graduate student housing apartment building that's located in downtown in the Jewelry District. So, really easy to get up to campus as well. We have a Brown University shuttle that runs all day, has extended hours when students are on campus at night. So if you're looking to get from College Hill down to your apartment in downtown, Brown makes it fairly easy and convenient to do that. We have a limited amount of housing available for graduate students. It's based off of a first come, first serve. So the earlier that you're able to get on that housing wait list, the earlier you can get taken off the housing wait list. The preference is given for first year graduate students, master's, PhD, and medical. There's a couple of different ways that you can navigate housing. We have some apartments available, some houses that have been converted into apartments in the College Hill area. So it really sort of depends on what you're looking for. We also get free ridership on the Rhode Island Public Transit Authority buses, which will take you all over the state of Rhode Island. And the MBTA is into Boston and Massachusetts. So we can go to the next slide. So, like I was saying earlier, I work in the Division of Masters in Professional Programs. Housed within the Division of Masters in Professional Programs is the Center for Master Students Excellence. One of the things that makes Brown really distinctive in the landscape of master's programs is we have dedicated resources for our master's students specifically. We understand that you're only with us for generally 2 years, some of our programs only 1 year. So, we understand you need to hit the ground running. You need to take advantage of all of the resources that we have at Brown, be connected to resources as needed in the classroom quicker. So we partner with a lot of centers and offices on campus to make this happen, whether that be connecting you with student health and wellness services, the chaplain's office, the Sheridan Center for Teaching and Learning. They do tutoring. They have a writing center as well as an English language program before students arrive on campus, really running the gamut and sort of trying to connect you and help you network outside of your program to be able to be successful during your time at Brown. So if we go to the next slide. We have a really extensive career support and professional development team through the Division of Masters in Professional Programs at Brown. We're really focused on layers of support. So Ted had some really great information he shared about at the department level, the co-op program, the faculty that you'll work with. We also, in the division of master's and professional programs, we have folks who are there to help advise you through your career process. So we have a STEM specific career advising. We have a master's career website that I would really encourage you to check out so you can see sort of what programming might be available to you that you can take advantage. But it's really all the way from when you start helping navigate what are you interested in, what sorts of companies have the type of role that you're interested in, resume, cover letter writing, your LinkedIn profile, all the way through to salary negotiation. And you have career support available after you graduate as well, which is really excellent. So we've talked about the department, we've talked about the division of master's and professional programs. We also have the Center for Career Exploration. They put on sort of more larger events at Brown, so career fairs, recruiting fairs. We use Handshake to post a lot of job and internship opportunities. Events that are offered through our career and professional development team are all done through Handshake. And then one of the great perks about attending Brown is that you have access to our alumni through Brown Connect. So we have really excellent, engaged alumni network that are interested in our students. So you can connect with them through Brown Connect. So yeah, that's sort of what the landscape of career and professional development looks like. Of course, if there's any questions about that, Ted and I are happy to answer those. So if we want to go to the next slide. I want to talk through the application process and requirements, which on the next slide we outline pretty well. So here's a high level overview of everything that we're going to require you to submit as a part of the application. So we're going to require you to submit transcripts from everywhere you've attended after secondary school. So if you have multiple degrees, multiple bachelor's degrees, a bachelor's and a master's, if you transferred institutions, we want to see the transcripts from all of the institutions that you've attended. Unofficial transcripts are fine for the purposes of reviewing your application. If you attended an institution outside of the United States, you do not need to submit a credential evaluation as a part of your application. Your unofficial transcripts will suffice. Your CV, your resume helps to outline your skills, your work experience, your personal statement, which is an excellent opportunity for you to have to show us that you're ready for the level of academic writing that the engineering programs are going to require of you. Make sure that you spend time with it, that you're proofreading it, and make sure that you're talking about your professional goals, your experiences, why you're interested in Brown, and why the particular degree program you're interested in, and sort of how that will help you meet your goals. It's a really great way for you to get in front of us to sort of show us who you are as a person. We have a holistic review process, so we look at every aspect of the application when we're reviewing your application. Some of our programs are also going to require a video essay that'll pop up as you move through the application. It's meant to be in real time, so we don't have like a prompt list. It's just meant for you to answer the questions sort of in real time. We have a cache of questions that'll be asked randomly. The letters of recommendation, we require 3 letters of recommendation for folks who are external to Brown. 3 letters of recommendation should come from folks who know you really well, who've taught you in the classroom, who've supervised you, who can speak more detailed about you than just, this person was in my class, they got in the top 10% of the grades, they showed up, right? That's a really vague letter of recommendation. We want to hear more than that. Like, how do you work in a group? How are you as a member of a classroom community? What are your skills as they pertain to this program? My tip here is ask early for letters of recommendation and provide your personal statement, your CV, your resume, so they can get the best picture of how they can position you successfully in the applicant pool through your letters of recommendation. TOEFL or IELTS is only required for folks whose native language is not English. We'll waive that requirement for folks who have a degree from an institution where the sole language of instruction is English, even if your native language is not English. And then we do not require the GRE for any of our master's programs in the School of Engineering. So if we want to go to the next slide. Here is a great screenshotable slide of all of our application deadlines per discipline. So we have a deadline coming up right around the corner, February 1st. That's the priority deadline. The earlier you apply, the earlier you'll hear back from us. So that helps you sort of move the needle on things like getting on housing wait lists, starting the visa process if you're an international student. So we encourage you to apply earlier. We'll release those first set of decisions from February 1st, and then we'll roll decisions out from there as we make them, every few weeks. So if we want to go to the next slide, ready to start answering questions. So if folks want to start adding things to the Q&A, this is just sort of how you can find us on social media. Definitely great way to get a sense of what's going on in the department. Also, if you look at events at Brown, that's a great way to get a sense of what sort of programming we're putting on, speakers we're inviting, classes that we're offering, things like that. And then if we want to go to the next slide, Folks are welcome to reach out to us directly if you have questions about the application, masters_admissions at brown.edu. I will also put my email address in the chat to start answering questions. So then we can go to the next slide and start answering some Q&A. Uh, is there a way to transfer your application from the MEng to the MS, along with letters of recommendation that have already been submitted? So I guess a good question here, Ted, is are students allowed to change from the MEng to the Master of Science after they matriculate?
And do you know the specifics?
Yes, you can do that after you matriculate it. Yep.
And on the application side too, Anne, like if somebody reached out to us and they wanted to switch from the MEng to the MS, we would do that, right? So the requirements are largely the same. So we would be able to shift your application over.
Yeah.
Awesome. So that's that question. Let me just open the questions that were asked in advance of the session just to make sure we covered all that.
There was one question about will a master's student be a good TA candidate, and we look for those opportunities, and we've had several great master's students be TAs, so that's very helpful.
Can I apply to 2 programs at once? Yes, you can apply to up to 3 programs maximum per application cycle.
Okay.
Folks from a non-engineering STEM background, how attractive are those candidates for our master's programs? What coursework do folks have to take if they don't come from an engineering background?
Yeah, I think a lot of times it's, I think like a background in mathematics, for example, would help. I know that's partially STEM, but you don't have to have a computer background to get into the ECE program. You got to have some skills with building systems, for example. So you may have a mechanical engineering background that you want to apply to a computer engineering role, for example. That's very possible. But we're fairly open. I think what we want to see in the application is just somebody like in the engineering space that has more of a logical mindset or has done some work to develop some logic and can deal with the complexities of a complicated system. But don't feel like you don't have the prerequisites for what we're looking for. I'm one of the readers for all the applications, and you'd be amazed at some of the wide range of candidates that we get, and some are terrific students and candidates for us, even though they may not have a STEM or a more typical background that you'd expect.
Fantastic. How long is the application review process typically? We generally, so if you apply by the February 1st deadline, you'll hear from us at the end of February. And then if you apply after that February 1st deadline, once we get all of those priority decisions out, then we'll start to review the regular round candidates who are complete and we'll release decisions every few weeks.
But we're motivated to review and return responses as quickly as possible because it's an anxious time for everybody involved. And let's be honest, we want to get the best candidates as soon as possible.
Can folks take classes or study abroad during the master's program? Uh, Not study abroad, but they can take classes at some of our partner institutions, right, Ted? Like Harvard, RISD.
Yeah, those would be local.
Yeah.
People do take leaves of absence. That does happen, right? And would have the statistics to that. But generally, you're coming to Brown to take Brown classes, right? And although we have these partnerships with these other institutions, just say, look, I'm interested in going to the University of Portugal because they have a great program in X. That's not something we have in our templates, if you will. So that isn't typical. But people do take time off and go to work or travel and come back and finish a degree? That's all that happens on a regular basis.
Uh,
Sorry, I hit answer live for the research assistantship
no
questions.
worries.
I meant to type back, but so yes, they are STA supplemental teaching assistant um opportunity for master students. But it's not guaranteed. The stipend will be 2,500 per semester.
I see.
Is there any advantage in the application process to deciding thesis versus non-thesis? No, right,
Not,
Ted?
not a factor. Not a factor. In fact, we don't want you making that decision until you really get into understanding what research you're interested in, who your PI is going to be. You can make that decision at the end of the first semester, and that's not going to hurt in any way in terms of applying for the school.
And then the last question we have is about the video essay and the questions. The questions aren't going to be content specific. So if you're applying to ECE, we're not going to ask you questions about ECE. We're going to ask more general questions from about you than that, really to get a sense of your communication skills, how you answer questions on the fly. So you don't have to worry about being quizzed about your ECE knowledge necessarily, but come to the table ready to talk, ready to speak clearly, answer the question. I think that's my biggest piece of advice is to make sure you're answering the question fully. So that's all we have for questions. Thank you so much, everybody, for joining. Thank you, Anne and Ted, especially for presenting and asking and answering questions. Other than that, have a great rest of your day, and we hope to see your application soon. Bye, everyone.